paper folding can be used to create a parabola. The way you do it is we take a piece of loose leaf paper, and the loose leaf paper's got these blue lines on it. And the holes kind of get in the way, so we're going to put the holes on top of the paper and just ignore them. What you do is you pick a point anywhere on the paper and label that F. Then you pick a point on the bottom edge of the paper and call that point R1. And you fold R1 onto F to create this fold. And that fold should be the perpendicular bisector between those two. Let me make that fold a little bit more accurate. That's good. Then, oh, I'm sorry. You should pick it so that the R1 point is on one of these blue lines. It makes it easier. Then from R1, you go sort of perpendicular, and you locate where the line, the vertical line that R1 is on, intersects the fold. We call that S1. And if we do this a few more times, I call this guy R2. Here's the fold. Here's point S2. Here's R3. Here's that fold. Here's S3. And if you keep doing it, what you'll find is that those S points ends up becoming a parabola. And this is because what all these points have in common is that when you fold R1 onto S1, if I draw this line also, this line segment has to be congruent to this line segment. There's a rule in math that any point on the perpendicular bisector is equidistant from the two endpoints. So here I'll draw this in. And this is true for any point. For instance, for R2, if I drew this line and this line, those two things would be equal. And it's a rule about parabolas that any point, that a parabola is the set of points so that that are equidistant from a given line and a given point. In this case, the given point is F1, and the given line is the bottom edge of the paper. That line that we start with is called the directrix, and the point is called the focus. So this means that any point in any line, there is a parabola that's defined by that directrix and by that focus. If the point is real close to the edge, you end up sort of a skinnier parabola, whereas if the point is kind of far away from the edge, you end up with kind of a wide parabola. So there's a relationship between sort of how far away the focus is from the directrix and how wide the parabola is. Well, the distance from the focus directrix is called 2p, and half of it, which actually gets you the vertex, is called p. Whereas the equation of the parabola is like y equals something times x squared. This is assuming that the vertex is at 0, 0. So I want to show you a relationship between p and the a value. Here's a specific example. Suppose I want to get the vertex at 0, 0, so I'm going to put the focus at 3, 0, at 0, 3. And the directrix, I'm going to put y equals -3. So whatever I put as this number is going to be that number. This guarantees that one point that's equidistant from the focus and directrix is halfway between the focus and the directrix on the y-axis, which is 0, 0. So by making this number the same as this number, I always get a parabola that has 0, 0 as its focus, which means y equals something x squared. We don't have any other, no b term, no c term. So now I'm going to show you how to get the equation of this parabola. We pick some point, random points on the parabola, call it xy, and then we also draw this vertical line. Now, because of the rule before with the parabola, it's equidistant, xy is equidistant from the focus and the directrix, so these two distances are equal to each other. Well, the distance from xy to the point 3, 0, using the distance formula, is the square root of x minus 3 squared plus y minus 0 squared. Whereas the distance from xy to y equals negative 3, point to a line can be annoying, but if the line is a horizontal line, it's not very hard then. It's just going to be like this distance is y, and this distance is 3, so it's just y plus 3. If I square both sides, I get x minus 3 squared plus y squared equals y plus 3 squared. And when I simplify that, I get x squared minus 6x plus 9 plus y squared equals y squared plus 6x plus 9. The y squares cancel out, the 9 cancels out, and when we add the 6x to both sides, over here, I get I get x squared equals 12y, or y equals 1 over 12x squared. So you should know how to do that process. In general, if I call this p 0p and y equals negative p, and I do the same process, I'm going to get y equals 1 over 4p times x squared. You can rework that yourself. So what this means is that the a value is 1 over 4p. And this means we have a shortcut. If I give you a question like this, where I say this is 0, 2, and this is y equals negative 2. So as long as these numbers match up, you can say the formula is y equals 1 over 4p times x squared. But p is 2 in this case, so it's 1/8 x squared. We could also go in the other direction. Whoops. We could also go in the other direction. If I have a parabola, that's y equals 2x squared. That's the a value. So a equals 1 over 4p. So 2 equals 1 over 4p. So 8p equals 1, or p equals 1/8. That means that we could put the focus at 1/8 here. This vertex is 0, 0. So 1/8 above the vertex is 0, 1/8. And 1/8 below the vertex is y equals negative 1/8.